All right, what we're going to do on these problems is focus on moving this green dot specifically. If you click it and drag it, it will move the function around altogether. If you grab the blue lines, it will cause them to stretch and reflect. So what I want to have happen is for us to pay attention to what is going on inside the function notation. And we're going to translate out from the practice we had before where we modified these numbers to see what the function did. Now we're going to follow the rule that they're telling us here, which is that this was a cubic graph. This is an x to the third parent function, and we're going to shift it based on these numbers here. This minus 5 causes it to go opposite of the sign, left to right. It's minus, so we go to the right 5. So the first thing I'm going to do is drag this green dot right 5 spaces. And then I go back and look at what's happening outside. Well, this plus 4 is outside. This is the function definition of x to the third. And you take all of these y heights that were here, and we need to add 4 to them. So this green dot, I now reselect it, and I need to go up 1, 2, 3, 4 spaces. This is my newly translated function. It went right 5, up 4. So right 5, up 4. And that's the correct function that I'm supposed to have plotted. So now we've got a square root function, parent. So this is the parent positive square root of x. And what we're supposed to do with it is not shift it from the green dot. The green dot would move it around. I'm not supposed to move this one left and right because there's nothing happening inside the x. This one is simply being multiplied by a factor of 1/3, but then we also have a reflection happening. So what I typically do is I multiply by the factor first and then reflect second. So I'm usually first here, second here. It doesn't actually matter. It's just that people usually get a little concerned if we're reflecting first. So I'm going to drag the dot right here based on our prior knowledge of what it does as a y height on this vertical line right here, just this one. I'm going to focus on this dot because it's easily divisible by 3. It's currently a y height of 3, and I need to multiply it by 1/3. So timesing it by 1/3 is going to divide it by 3. 3 divided by 3 is 1. So the new height for this dot should be right here at 1. And again, I chose that dot because that's easily divided by 3. Notice this dot's not on a grid line. This line's not on a grid line. That's because that would have been 2 divided by 3, and this one is 1 divided by 3. So this one's at a third height. This one's at 2/3 of a height. That's not very convenient to plot a dot. So now that is the first part. I'm going to clear the screen there. And then what I want to do is take care of this negative sign now. So all the negative sign does is whatever you've done with compressing it, all these dots just need to reflect over the x-axis. So I just need to drag that dot right down to -1. So it squished 1/3 as high, and now I just reflect it to go to the opposite side of the x-axis. And we have it. So now in this example, we're going to take a look at a cube root function. And the cube root is the parent here. This is the graph that's here, these dots plotted, is just the cube root of x without the extra numbers in there. And so we're supposed to take that function and shift it based on this -3 and this +1. Well, the -3 is in there inside the function with the x over here. And so what that means is this is my left or right move, but it's opposite of the sign. So since -3, I actually go to the right 3. So I'm supposed to take this green dot, we'll drag the whole function right 3 spaces. And then once I've done that, I'm going to move it my vertical shift up 1. So this is up 1. So I'm going to grab it, drag it right 1, 2, 3 spaces, and then just go up 1. This one doesn't have a stretch or compress, so that's the culmination of this transform. Now we have a cube root of x graph that has a horizontal translation with the -3, which is going to cause us to go to the right 3. But then I also have a reflection with the -1. What I typically focus on before I shift left or right, up or down, I try to reflect it first so it's less confusing to reflect. Now this one's not going to matter because it's just a horizontal translation, but when you do a vertical translation, it can get a little messy with people, how they think about their reflections. So I'm going to reflect it first to keep that pace. Now, what that means is I grab like a dot like this one, it goes exactly over the x-axis. So if it's at +2, it goes to -2. If I grab this dot, it goes to -1. If I grab this dot over here, it's at -2. It actually reflects up to +2. So grab it, drag it, reflect it, and notice if you move and kind of slide off to the right and you're like, oh, it goes to a height of 2, well, now you've got the wrong graph again. So start over, stay on the vertical line and go up 2, or up to +2 if you grab that one, or whichever one you grab, and it'll be reflected properly. Then I take care of my horizontal translation, right 3 spaces. And that would be the correct shifted version. This function is the negative cube root of x minus 3 graph. Now we're going to stretch and horizontally translate a absolute value graph. This is the absolute value of x, y equals x, absolute value of x. Our job is to multiply by 2, which makes it twice as tall. And then we're going to move it to the left 1, because we go opposite of the sign. Because it's a plus sign, we're going to go the negative direction. So I'm going to grab and multiply, I do the compression and stretch first. So in this case, I'm timesing any of these dots to be twice as tall. The green dot, if you multiply that by 2, it's supposed to still be 0, so it doesn't change. The blue dots change because of the 2, so I'm pick any of them and times it by 2. So 2 times 2 should be 4, so drag it on this vertical line. Don't slide out to the right. On this vertical line, go straight up to 4, and that would get you the stretched part. Now I just need to grab the green dot and move the whole function left 1. And that is my translated absolute value graph, times by 2, twice as tall, left 1. So now we're going to compress and then vertically shift a 1/4. Now, what I said on the last graph is I try to take care of my stretch or compress before I translate, especially when it's a vertical translation. If I grab this up, grab this bottom dot and drag it up 4 spaces to be right there, it's a little bit more confusing to think about how to make these blue dots go to be 1/3 as tall as they are currently. It's easier to start with their standard distance from the x-axis, because here I can pretty easily think about which one of these heights can I make conveniently 1/3 as tall as they are. Well, that's going to be the y height of 3. If y is 3, that dot, and I times it by 1/3, in other words, divide it by 3, it should become a height of 1. So it's very convenient to just say, well, on this line, that dot needs to go down to 1. So I take this dot, grab it down to 1 first. Once I've got that taken care of, now I take care of the translation vertically up 4. 1, 2, 3, 4. So it's a lot easier to see the vertical compression before I do any vertical shifts. And especially if I get a negative reflection and a vertical shift. So let's say you have a reflection and a vertical shift. So what I would encourage you to do is to reflect it first by multiplying by negative. So any height that's up here, go exactly over the x-axis. That's what the negative caused. And then grab the green dot and go up 1, 2, 3 spaces. It saves any confusion, because what happens is people go, oh, I go up 3, and then they're like, oh, I reflected over the x-axis. So then they go, all right, well, now I need to go down to -3, and then this one needs to bend down like that. And you get all sorts of weirdness happening. But it's actually supposed to be you reflect just the function the way that it is. So you go over to the -2, so that's the reflection. Or you could have picked the +1 to -1, whichever one. And then now drag it up 3 spaces. So don't go up first and then try to jump over the x-axis, because you can imagine somebody thinking that you drag it up first and then I should reflect it down over here, and that this would be my right answer, which it's not. It should be, as we showed a second ago, this one. Okay, so anytime you have a reflection mixed with a vertical translation, take care of the reflection first before doing any horizontal vertical transforms. So just one more take like that. If you've got a negative here, +4, I would not move it up 4 first. I would reflect first and then move. So we reflect it and then move up 4. My fear is I've seen students move it up 4 and then they reflect it down over here and get the wrong answer. So I've seen frequently this be the wrong answer that people gave me. And I look and I try to help them. I'm like, well, it's supposed to go up 4 and you went down 4. And they're like, well, I don't understand. Well, the reason why, again, is because you're supposed to reflect first and then vertically translate.